This video is on the topic of chemical wastes, presented by Arnold Villaro. Chemical waste is defined as the unwanted material produced from a chemical reaction. It also includes expired products no longer needed for experiments. Examples of chemical wastes include unused chemicals like acids or bases, sharp objects, plastics, waste papers, and rubbers. Poisonous gases resulting from chemical reactions are also examples of chemical wastes. Chemical waste is classified into two main categories: hazardous chemical wastes and non-hazardous chemical wastes. Hazardous chemical wastes are those that can endanger the life of living organisms. Non-hazardous chemical wastes are those that do not endanger the life of living organisms. Hazardous chemical wastes include materials that are ignitable or flammable, reactive, corrosive, or toxic and poisonous. Ignitable or flammable wastes include gasoline, some paint thinners, adhesives, kerosene, and oil-based paints. Examples of reactive chemical wastes are lithium batteries and sulfur explosives. Corrosive chemical wastes typically include expired acids and bases found in a laboratory setting. Toxic or poisonous wastes include substances like sodium hydroxide, potassium, hydrochloric acid, and sulfuric acid. Safe ways to dispose of chemical wastes include using normal waste bins, special controlled waste containers, draining with a lot of water, recycling, and incineration. Normal waste bins can be used for non-recyclable plastics, pieces of wood, rubber, and dirty papers. Controlled waste containers are used for disposing of sharp objects, broken glassware, sample tubes, and items contaminated with hazardous chemicals. Draining with a lot of water is suitable for harmless soluble inorganic salts, contaminated acids, alkalis, and detergents. Materials that can be recycled include unbroken glass, packing waste, and paper. Incineration involves burning waste in an incinerator. Wastes like syringes, needles, organic and inorganic solvents, paraffin, and mineral oils are incinerated. Designing a scientific investigation is the systematic process of finding an answer or solution to a problem or observation. The components of a scientific investigation are problem identification, formulation of a hypothesis, experimentation, observation and data collection, and interpretation of data. The final component of a scientific investigation is the conclusion. Problem identification involves asking questions about the natural world, such as what causes rusting, or why do plastics not decompose easily? A hypothesis is a guessed answer or solution to a problem. It is formulated based on the scientist's experiences and knowledge. Experimentation is a series of investigations intended to accept, modify, or reject a hypothesis. Observation and data collection involve correctly recording observations and stating the correct units of measurement, often using tables. Interpretation of data means explaining observations and trends in relation to the aim of the experiment. The conclusion is drawn from the collected data. The hypothesis is accepted if correct or rejected if wrong. A pure substance is a material that has a constant composition and properties throughout the sample, containing no contaminants or impurities. The three basic tests to check for purity are measuring the melting point, boiling point, and chromatography. A pure substance has a fixed melting point. For example, pure water melts at 0 degrees Celsius. A deviation from this indicates impurity. Similarly, a pure substance has a fixed boiling point. Pure water boils at 100 degrees Celsius. If the boiling point is different, the water is not pure. Paper chromatography is used to separate mixtures of soluble substances. Substances are carried by a mobile phase moving through a stationary phase. The two phases of chromatography are the stationary phase and the mobile phase. The stationary phase is the part of chromatography that is in a solid state, such as a filter paper. The mobile phase is the part of chromatography that is in a gaseous or liquid state, such as a solvent. A chromatogram is the pattern formed by substances that have been separated by chromatography. Purity can be determined by the spots on the chromatogram. A pure substance produces one spot, while an impure substance produces 2 or more spots. This scene shows a chromatogram. The relative flow value, or RF, is the ratio of the spot distance to the solvent distance, calculated mathematically as spot distance divided by solvent distance. Both distances are measured from the center of the sample. The relative flow value has no units of measurement. This slide shows a visual representation of how the relative flow value is calculated. Here are the relative flow values for the components shown in the previous scene. Component D is 0.8, component C is 0.6, and component B is 0.2. Chemists perform various chemical tests to determine the identity of a compound or a gas, including tests for water, ions, and gases. An ion is a charged atom. Ionic compounds have two types of ions: cations, which are positively charged, and anions, which are negatively charged. Commonly tested aqueous cations include calcium, aluminum, zinc, copper, iron 2, and iron 3.